So we'll continue from last class. I will try to finish this particular chapter and we'll move to the demonstration of ANSYS software after that. Okay, so last class we finished with this slide and we saw that there are different types of analysis. Again, if you recall, we have strength, stress analysis, bending, torsion, buckling, and different types of analysis which are listed here. The analysis can be analytical, numerical, or experimental. And we saw that in very few cases we will have analytical solutions or closed form solutions. Therefore, we always go for numerical procedures like finite element analysis or some other method to do the analysis. And experimental procedures are also used, especially if there is a new product, then we will use experimental procedures. Okay. It's also important that we go through the standards. Standards can be associated with materials, with the design procedures, technical specifications with respect to your design, etc. So these are technical standards. There may be standards associated with how to dispose of materials safely, and in case you have poisonous products being rejected by your particular machine system, then there will be environmental standards associated with it. And we also have to deal with how to dispose of materials once the life of the product is over. Besides that, there will also be quality standards. Quality can be associated with manufacturing quality, product quality, etc. Okay, so standards are there associated with every field. So here you can see engineering design with respect to engineering design, you have all these standards. So there are standards associated with maintenance, with serviceability, reliability, quality, safety, aesthetics, everything, almost everything involved in design has a standard associated with it, even with for product life cycle here. Okay, so we will see how to get these standards. Also associated with manufacturing, we have different types of standards here. So this slide gives you what are the different types of standards that we should look for. Okay, so I will come back to the standard later. We will go through what are the different kinds of computational tools we can use in design. We have the CAE softwares like your Autodesk or AutoCAD, etc. So this is mainly a software to create just the geometry of the system, so that you can provide that geometry to your manufacturing department. There may be additionally computer aided design softwares. Under this, you have the finite element analysis softwares. For manufacturing, you may have CAM softwares again associated with it. We have already seen under CAD, we have all the engineering analysis softwares. Additionally, we may use some kind of math solvers like MATLAB or any other programming language or any other tool associated with solving math problems. Besides this, we might use some of the journals. Okay, so especially if you want to get information about new things, you might refer to some journals, existing patents, etc. Again, all these are online libraries. Besides the libraries like your sciencedirect.com. Okay, so for example, if you want to take a look, you want to check what kind of papers are available, ScienceDirect is a very good reference point. So you can go here to sciencedirect.com and look for particular keywords. For example, if you are looking for some new information on gear materials, okay, so we can search with the keywords and you will have a list of papers that are published on this particular case. Okay, so you can look through that. Some of them you have free access, some of them you will not have access to the material. If you are inside the University of Bahrain campus, most probably you may have access to some more papers than what you have access here. So let's go back here. US government, for example, has a website for searching for patents. So you can go uspto.org if I remember right. Okay, so I think maybe com. So let's do a Google for USPTO. This is the United States Patent Office.gov. So it should be .gov. And if you go here, you can look for particular patents. Let's say I want to look for something related to flywheels. Let's see if I will be able to search. And you can probably see some of the patents being listed. If you click on any of the link, it will take you to particular product. Okay, so you can click on that. Okay, so again, we don't have here. Better to do the patent search in Google directly in that case. So USPTO, and I want to look flywheels. So if you do that again from USPTO website, you will get many patents here. For example, this is a patent with related to your let's say here. Again, this is not the patent. Okay. Okay, so here this is a particular patent that is being listed here related to flywheels, and you can search for patents using Google. Okay. Okay, so these are some of the ways you can look for material online. Besides that, you can also look for brochures, catalogs available which are online, and check for any available designs. Cost is also very important, depending upon what kind of manufacturing process you choose. Depending on it, you can have very high cost or low cost. Now, depending upon the tolerance you choose, the cost of operating a machine may increase or decrease. So here you can see on the y-axis you have the cost, on the x-axis is the tolerance that you will choose. The more precise the tolerance is, you can see the tolerance limits are reducing as we go towards the right. The higher the tolerance limits, what happens is the cost increases exponentially because we need to use special manufacturing equipment to maintain very high tolerance limits. Okay, so we have to choose tolerance very carefully with respect to our product. Again, there is a break-even point analysis. In case you choose two different manufacturing equipment, this is the automatic screw machine, hand screw machine, and you have the plot of the cost with respect to the number of units you produce. So here you can see on the x-axis number of units you produce for a particular product. The cost is here and two manufacturing processes. And as you increase, you can see one of the processes intersects with the other. with respect to the cost. What it means, this is the break-even point. If you cross this point, or if you are below this point or above this point, then you have to choose the particular manufacturing process which costs you the less. So simple graph of cost analysis. Sometimes the product may have liability loss. Most of the times you are going to have liability loss. Whenever you produce a product and goes into the market, the safety of the user, customer use is very important, and there may be laws related to it, very strict liability laws. If anything happens to the customer, or maybe the product does not function to its required level, then people can take you to the court. So there will be laws associated with it, and you have to be aware of these laws as well. Okay, so let's quickly go to the difference between strength and stress. Can one of you tell me what is the difference between strength and stress? Anybody? What is strength and what is stress?
The strength is the property of the whole material. The stress is on one point in the body.
Yeah, so strength is the property of the material, while stress is the state of a particular component under externally applied load. Okay, so there is a difference between two. So let me just connect my iPad before I continue. Okay, so just 1 second. Let's see here. Okay, connect info. Yes. All right. So stress we can write as internal force over area of cross section. This is how we calculate. However, the strength properties are obtained from tensile tests or some other tests, maybe torsion test, etc. Okay, so some examples are Young's modulus, yield strength, ultimate tensile strength, etc. These are the examples of strength. And stress is usually compared with the strength. For example, we can check whether your sigma is less than or equal to sigma y. So from here, we will know whether the particular component will fail or will not fail. So we will deal with this in more detail, especially in 2D and 3D in chapter 3 and 4. Okay. Okay. So whenever you obtain properties and whenever you obtain the loads which are applied on your system, sometimes most of the times there will be uncertainty associated with these things. So what are the common list of uncertainties you can expect with respect to your design? If you take a look at it, it could be in terms of composition of the material which you use to produce your product. Composition may not be uniform. Okay, and also between, let's say you are using uh, uh, fasteners, bolts and nuts. You may buy bolts and nuts from a particular place, but no two bowls will have the same properties, exactly the same properties. There will be some variation in the properties because of the composition of the material is varying, and therefore there is a variation in properties. Okay, there may be variation in properties from point to point on the material which we use. So this is also there, uncertainty with respect to that. There may be effects of processing locally. For example, if you are doing a welding operation locally, wherever you do the welding operation, over there you will see the properties have changed. Okay, so simple case is weld. You have two plates, and I use the welding operation to join these two plates around this welding. The properties would have changed because we have heated the material, and the properties will change. Effect of thermomechanical treatment on the properties. Sometimes we want to improve the properties of the material and we do thermomechanical treatments. What are these thermomechanical treatment? You could heat the material to a higher temperature and also apply mechanical loads on the material, and that changes the property. So how much it will change the property, we are not sure. So we are uncertain about that. Intensity and distribution of loading. The classic example is a bridge, and we do not know exactly how much load, what is the exact load acting on the bridge. There is a complete range of loads acting on the bridge, and it depends upon the time. The load keeps changing, etc. So uncertainty with respect to loading. Validity of mathematical models. What are these? Mostly, if you see, the simplest mathematical model we use is sigma is equal to E times strain. So this is a mathematical model. Is this true for all the materials, all the case, all the time? No. So there may be certain some uncertainty because the properties itself are changing, and even the relationship may not hold good for most of the cases. In the case of metals and alloys, there is not much change here. However, if you take a material like concrete, then there is some uncertainty that is involved. If you take some other material like rubber, which we probably use as shock absorbing materials and structures, again you will have very complicated stress strain relationships, nonlinear relationships. Again, there is a approximation of these properties. For example, you may have sigma expressed in terms of power law. So instead of using E here, in case of a material like rubber, you may have square plus B epsilon plus C. So simple form of nonlinear relationship here between stress and strain. A, B, C are material constants. Intensity of stress concentration. When the geometry of your component is complicated, it has holes, etc., then what is the effect of stress concentration? So that is also uncertain. There is an amount of uncertainty with respect to the stress calculations here. Influence of time on strength and geometry. As years, so for example, most of your products, they are supposed to survive for several years, and over the period of time, how does the strength properties and how does the geometry of your product change? There is uncertainty. Why does the geometry change? If you have two parts rubbing against each other, they will undergo wear and geometry changes. How does it change over a period of time? We are uncertain. How does the strength of the material change? For example, most of the materials undergo degradation. When I say degradation, corrosion. Foreign materials, they seep into the into your product and change the properties of the material, especially when you see offshore material, offshore structures. These are structures present inside the sea or under the sea. Okay, so in the presence of salt water, how does the property of the material change over a period of time? We are unsure. Effect of corrosion, effect of wear, we have already talked about that. And we are also uncertain with regard to the list of uncertainties. There may be other uncertainties which we do not even know about. Okay, so how do we deal with uncertainty? We use stochastic methods. Stochastic methods are based upon probabilities. We will not go through these methods in this particular course, but if you are interested, there may be a separate chapter dealing with probabilities and stochastic methods. Okay, especially in the 8th edition. The new edition does not have this chapter. Okay, so in your textbook, 8th edition has this chapter. 8th edition. There is also a deterministic method, where this is the method we will be using. We will come up with a factor of safety. So first we will come up with a factor which is called as a design factor. When through experiments we confirm that the whatever design factor we use is okay with a particular application, then the same design factor, when it is realized through experiments, becomes factor of safety. Okay, so how do we define design factor? Design factor is defined as the ratio of loss of function parameter by maximum allowable parameter. What is this parameter? Parameter could be load, externally applied load, and internal reaction forces, or it could be stresses which we calculate, and the strength values of your material. Okay, so we can write loss of function stress by maximum allowable stress. Okay, so the maximum allowable stress will usually depend upon the material property. So the same formula is written slightly in a different way. Here there is again the example is provided. Here we have loss of function strength and by allowable stress. Okay, so this is the ratio given here. In the numerator we have the strength property, on the denominator we have all the stress calculations. Okay, so the factor of safety is the realized design factor of the final design, including the rounding up standard size of the available components. There is also reliability. How do you calculate the reliability? If you know what is the probability of failure, reliability can be calculated as 1 minus the probability of failure. What is probability of failure? Suppose you have 1,000 parts that are manufactured, and we find that by tests that 6 parts are failing. So usually how do they check this? Among the 1,000 parts, they may select certain amount of materials, maybe 100 parts they will select. They look for any defects in the material, and then they will figure out what is the percentage of the materials or the product that fail. Okay, and from that we can figure out what is the probability of failure. Probability of failure in this case is 6 over 1,000, considering all the 1,000 parts, and we can figure out what is the reliability. Reliability will be 99.4%. In many of your design calculations, we will use this reliability to extract other properties. Okay, so we will see these examples later. If you have several components put together, each component has a reliability Ri. Okay, the total reliability of the system in this case is given by the product of the reliability of individual components. And this is how an example is given here. A shaft has two bearings having reliability 95 and 98%. The overall reliability for the shaft system is given by multiplying the reliability of each bearing. Okay, so nominal size and tolerances. So we will have a brief discussion about tolerance here. So nominal size is the size you get by design calculations. For example, it could be the shaft size, diameter of the shaft, which you calculated according to your design. However, when you go for manufacturing, you cannot produce a shaft with the exact dimension provided by the nominal size. You have to give some allowance for the maximum variation in the diameter. So therefore, you have to give the maximum and the minimum change in the diameter. So why do we have this problem? Whenever you whenever you use any manufacturing machine, the machine undergoes vibrations. The machine itself vibrates. The tool the machine uses to cut or make the different parts also undergoes vibration, and therefore there will be variation in the nominal size as you cut the material. For example, if you use the lathe to produce a shaft, the shaft will not be produced exactly to the dimensions. However, the diameter will vary from this end to this end, maybe slightly shorter. I have exaggerated here. So it may vary by this much quantity, maybe in terms of inches. Okay, and there will be variation in the dimensions. So how do we specify these variation, allowable variation in dimensions for manufacturing? We mention it through tolerance. So what is tolerance? Tolerance is the difference between the maximum value of the dimension and minimum value of the dimension that is to be maintained during manufacturing process. So this is tolerance. And we have seen earlier that if we provide too tight of a tolerance, that might increase the manufacturing cost too much, because we have to use very sophisticated machinery for very high or tight tolerances, where we have to reduce the vibrations in the machine using very sophisticated control systems, and it will increase the manufacturing cost. Okay, so let's see here. So there is the bilateral tolerance here. You have the nominal size with a variation to a minimum level and a maximum level. So you have both the negative and positive quantities become equal. Or it could be a unilateral tolerance where you do not allow any change below, but you can allow some change above the value of the nominal size. So this is unilateral tolerance in the when you can allow changes in the upper limit. You can also have conditions where you can change in the lower limit. Most probably this is for the bore diameter. So for example, if you have a shaft and you want to fit it inside a bearing, so the bearing, in this case, if you imagine this to be the bearing, ball bearing here, the bore diameter of the bearing here, you cannot allow it to get any smaller, maybe, and in that case you can allow some variation in the upper limit. For the shaft, you can allow variation in the lower limit. Simple example here. Clearance is another definition here. We have to give reference refers to the difference in sizes of the two mating cylindrical parts. For example, again, the bearing and the shaft. Okay, so these are two mating parts, or it could be bolt and the hole. Okay, so the difference between the sizes is given as the clearance. Okay, so depending upon the clearance you provide, clearance can be positive, can be zero, can be negative. So depending upon that, you can have the interference fit, you can have clearance fit when it is positive, etc. Okay, so we will see again there are standards associated with tolerances and clearances. Okay, so here assumes the internal member is smaller in the case of clearance. The internal member is small, then the external member, diametral clearance, difference between the two diameters, radial clearance refers to the difference in the two radii. It is interference fit if the opposite holds true, that is the internal member has higher diameter while the external member has lower diameter. That means you have to force the internal member onto the external member, maybe using some hydraulic machines. Most of the times the fit between the shaft and the bearing is a interference fit. Allowance is the in between the minimum stated clearance or the maximum stated interference for the mating parts are within certain limit. Okay, so you do not you can think of allowance as something in between interference and clearance. Okay, so I'm not going to go through this responsibility, ethics, etc. You can go through this by yourself. Standards and codes. Okay, so what are standards and what are codes? Standards are usually set of specifications which are provided for parts or materials or processes by professional organizations like ASME, ASTM, etc. ASTM, etc. They provide standards. Okay, so what do they provide? They provide standards for parts. For example, if you take bolts, they may provide what are the standard size of the bolts that can be produced by a manufacturer. If you take materials, what are the standard composition limits and how you identify these materials? Those can be provided by organizations like ASTM, American Society for Testing and Materials. For processes, especially for chemical processes in your petrochemical plants, you may have standards associated with it. Why do we have these standards? The purpose is to have uniformity. Why do we need this uniformity? Not every manufacturer will be able to produce every part they require. Sometimes they have to outsource. What is outsourcing? That means they have to buy it from some other manufacturer and they will simply assemble it. So in order to allow the manufacturers to obtain materials from different places, there should be standards associated with it, and there will be standard sizes of bolts, etc., which they can obtain from these standards, and just the mention of the standards will give them all the details to the other manufacturer, and they can produce the product and give it to them. Okay, so this is for uniformity, for efficiency in terms of cost, in terms of loss of material, etc. Okay, so when a manufacturer knows the standard sizes of the product he or she should produce, then that leads to reduction in costs you can produce in bulk, and it leads to reduction in cost for the manufacturer. You can also specify the particular quality for the product that is produced. It limits the multitude of variations. So standards, we understand what is standard. What is code? A code is a set of specifications that is usually followed by an industry within the industry. The codes could be given by industries itself, or it could also be published by professional organizations. So usually such codes, they are available for, let's say, one example would be constructing your big tanks in your oil refineries. So on the field, they will have to produce these big petrochemical tanks within which you can store different petrochemical products. All the pressure vessels which are designed in the in refineries, for example, if you take a look at it, you will see these pressure vessels are constructed right in the field. Many of these pressure vessels could be constructed right in the field. So set these, how do you construct them? Through a set of specifications, guidelines given by the code. Okay, so again, this code could be given by professional organizations or could be developed by the industry based upon standards. Set of specifications for analysis, design, manufacture, and construction of something. That is called as a code. Why is it done? It's the same reason as the standards. You have a degree of safety, efficiency, and you can maintain performance and quality of the product. Okay, so it does not imply there is absolute safety. Still, there may be problems with respect to safety, even when you follow the code. Okay, so we have seen the difference between standard and codes. So what are the different standards which are available? So these are some professional organizations which publish standards. In the list, you can see, for example, aluminum manufacturing will consist of standards published by Aluminum Association. If you want to select a bearing, ABMA publishes. Gears, AGMA, American Gear Manufacturer Association, American Bearing Manufacturers Association. AISC publishes standards associated with steel used in construction. Again, AISI also does the same thing, especially if you use steel. AISI standards can be used to identify the materials. ANSI also publishes standards with respect to various things. You have for refrigeration and air conditioning, ASHRAE standards. ASME for pressure vessels and materials, ASTM again for materials, AWS for welding, etc. Okay, now here you can see some of these standards organizations, they even publish standards on how to write a standard. So they even publish standards on standard. Okay, so for example, British BSI is one of the oldest organizations, and they write a standard on how to create standards for various cases. Okay, so for example, bearings or gears, how to create a standard for these particular products, they give you a guideline. British Standards Institute gives you the guideline. So here in this block diagram, you can see, okay, what are the various standards here. For example, standards associated with certain objective functions. The functions itself could have standards. Some processes could have standards. products or individual machine elements could have standards. How to assemble products, they have standards. For entire product, they have standard. For example, if you are designing a robot or some kind of a machine, CNC cutting machine, okay, computer numerically controlled lathes, for example, in that case, you have a standard associated for the machines. There are standards for design methodologies that is to be used for different products. Again, standards associated with that. Standards with manufacturing methodologies. Yeah, there are standards associated with environments, and then finally quality. So why do we have these boxes outside? What does it mean? That means if I take the quality standard might include all these standards. It will take into account environmental issues, it will take into account production or manufacturing methodologies, design methodologies, and all the way up till this point. Okay, so the quality will take into account everything. And if you take environmental related standards, again, whatever is inside will be included. Okay, so BSI we have seen publishes standards for standard. And you are given also the list here. For general principles, this particular British standards standard can be used to build the context, aims, and general principles for writing a standard. And similarly here. Okay, so let's take the example of discrete products. What are these discrete products? It could be your air conditioning system. It could be your vehicles. It could be pressure vessels. So these are all discrete products. Discrete products are usually a combination of different machine elements put together, assembled together to give you a particular function or combination of functions. So some of them standards associated with it are for example, air conditioning systems. ASTM gives you, for example, standards associated with particular tests which are to be conducted, ASME for pressure vessels, and similarly you have all these standards. So let's see here. So I have the website being listed. So similarly you have for control system lists of standards. Whenever you do your senior project, you need to go through all these slides and you will know which standard to pick up in your particular case. For your discrete product, this is the list. If you are using a control system, then one of these standards should be mentioned. If you want to use a particular material, you may follow ASTM or some other standard to identify the correct material you are using. Safety standards, especially if you need to operate your particular product, are there any safety standards associated with it? Again, these are the list of standards organization. Quality, if you are manufacturing a particular product, again, these are the different professional organizations. Okay, for quality, reliability, again, maintainability, you are given. For product life cycle, again, you are given different standards institute. Now, how to know which standard to use? So let's see here. Click on this particular website. No, maybe I should open it. New tab. Okay, so when you go to this particular website, it will help you to figure out what are the standards for your particular case. Here you are given certain keywords followed by description of a discrete product or a process, etc. So let's try to get some design standards for a particular discrete product. So let's say design. Let us consider the product as a pump, and I want to search, and you can see here standards associated with rotodynamic pumps. Okay, so there are list of standards which are given for you here. This is how you look for particular standards. Let's see, go to one second page again. You have what is this? Okay, so it is not with respect to your pump. See here. Yes, so design of heat pump. So again, you have in the second page different list of pumps. Again, you cannot have access to these standards. At the least, you will be able to know what is the standard that is to be used for the case of pumps. Again, go to page 3. You have different kinds of pumps that are used for different cases. Let's see component of a discrete product. Okay, so I want to see for gears given here. Okay, and I search, again you get different standards which are available. Okay, so we have about 4 or 5 standards. Again, you can see what kind of standard is to be used in this particular case for high point gears. These are the standards. Okay, so we can use for particular machine element or for a discrete product. We also have process. Okay, let's think about any process, any chemical processes. Let's look for any petrochemical process. Since I'm not aware of any petrochemical processes, so I'm going to look for any particular process. Okay, so steam cracking process. So let's try that. I'm going to put steam cracking. Let's see if we get any result. Okay, so there is no particular result. If you know any particular process, in that case, you could look for the standards associated with the process. So since I am not aware of any particular process, I'm going to skip this. Okay. Right, so let's go back here to the slide. You want to look for life cycle, any design standard associated with life cycle. So let us try here using life cycle for particular product. Let's see batteries, lithium battery or any other battery. Let us again. Let's see. I don't know if it will work. Looks like I'm not using it correctly. Sorry. So I think it is under the life cycle heading. Okay, so I should remove this battery life cycle. Okay, so it doesn't work. Lithium batteries. Apparently it doesn't work here. Let's try for gears life cycle. Use this one. Gears. No, doesn't work. Okay. So it's product and life cycle. Let's try for quality here. I'm going to try with quality and gears. If there are any quality standards, again, it doesn't look like we are getting anything. Should I put the design gears here? Okay. Quality product, quality process. Okay, so here the keyword design seems to work in this particular case. I will figure out what is the keyword I should use to get, for example, the quality standards with respect to gears. Maybe I used just a single, not plural. Yes, so that was the mistake. I should not use plural word gears, rather quality and gear. And I get the quality standards associated with the particular product. Again, we can use the component or the product, and if I want quality standards associated with pumps, let's see, again we have the description of the quality standards. So similarly, you can use different keywords to obtain the standards associated with these particular cases. For example, I can even look for safety standards instead of quality standards. And if I search for it, again, I will get safety standards associated with the product. So this is how you can obtain what is the standard to be used with respect to a particular product or a component. Okay, so any doubts here? In your senior project or your course project, you will be asked to cite the standards, and you have to come up with the standards. Let's look for design connecting rod. If you can get any standard, looks like there is no standard associated with this. Okay, so how do we use? Okay, so it doesn't recognize this particular component, so we cannot get the design standards for this particular case. However, if you know what is the material to be used for connecting rod, you can look for standards associated with the particular material. Okay, so we are done with this slide. If you do not have any other doubt, I'm going to go to the next slide. Now we are going to see how to use the ANSYS product. Have you guys installed ANSYS in your system?
Yes, doctor.
Okay.
Yes, doctor.
Okay, so
Yes.
please wake up, don't sleep. We will go to the ANSYS system. So in ANSYS, what we can do? We can do structural analysis or finite element analysis for structures, for static structures or dynamic structures. We will start with static structures. So this is an example of finite element analysis for your uh, implant, hip implant. This is the hip implant and it is inserted into the bone, and we want to do some kind of stress analysis on the system. So this is an example showing the stress analysis. There is also a crash simulation. Uh, this involves creating a CAD model, which is quite complicated. Takes quite a lot of time. Uh, Here we have analysis of the dummy here. You seat a dummy and do crash analysis here to figure out what are the forces acting on different body parts. And by finding these forces, we can figure out whether injury to a guy sitting here will take place or not. Again, this is crash analysis here. So these are some of the typical finite element analysis work you can do. Knee protection here, again penetration and buckling phenomena. When you have a column, there is a buckling phenomena, then you can search, you can do finite element analysis. Another one is underwater explosion or even explosions on impact with a solid can be simulated. Okay, so this is different one, missile detonation, cutting of a particular metal surface with a tool. Even this can be simulated. Structural analysis for your bicycle frame, more crash analysis, earthquake response of buildings. So you can see so many different types of stress analysis could be done. So most probably I'm going to give you a group assignment. Okay, I will give you a group assignment where as a group you will work on thermal analysis for a chip as shown here. So what you will do, you will build a CAD system for a solder joint for electronics, and then you will be asked to do thermal analysis. We will assume a source of heat from the electronic chip, and there will be heat transfer between this chip and the base, and you will have to do stress analysis, for example, on the contact between these parts. So these are connects for these chips, and these are soldered joints here. What is the stress developed in these joints? You will be asked to do simple stress analysis as an assignment. Okay. Okay, so I'm going to stop here with respect to this chapter. I'm going to directly go to your ANSYS. How do you open your ANSYS? Left click on the window on the bottom left corner here. Once you do this, you will have a list of the programs installed in your system, and you will find a folder ANSYS. So if you have installed ANSYS version 2022, okay, whatever version you have, that is okay. Click on the folder, it will expand. Once it expands, go down all the way and try to find out where is the workbench. Once you find the workbench, click on it, left click on it, and it will open the workbench for you. Once the workbench is open, on this particular toolbox here, you can see this toolbox, you will see list of programs that is available within the ANSYS system. So there are many programs here. You have fluid, you have couple field transient, couple field static. So these are ready-made systems. For example, the coupled field transient could mean a combination of mechanical forces, fluid flow, heat transfer, etc. So when you have all these coupled together, you will use this particular module for creating your models. In our case, we are going to go for the simple case, specifically static structural system. Okay, so look at static structural here. Left click on it, select it. Once you select it, press your left click on your mouse, keep it pressed, drag it to the right window here and place it inside the rectangular region here. So you can see here the rectangular region when I am outside is green. When I take it inside, it becomes red and it displays create standalone system. Once you bring the cursor inside, release your left click. Okay, so now it has created a model for you. And let's see, I'm going to create the model. I'm going to give it a name. Here I can change the name. Let's say I'm going to create an elbow pipe. Okay, again, if you okay, so double click on it and can change the name. Okay, so once you have created this model, you can see here engineering data with a green tick mark here. That means the data has been already input for you automatically by the ANSYS system. However, if you want to edit the data, right click on it, edit, and it will open up another window for you. So here automatically we have structural steel selected for your particular system. Okay. Okay, so by the way, did you guys install ANSYS in your system?
Yes, doctor.
Okay.
I didn't.
So I will go through this slowly.
Discovery, as you said in the
Discovery.
lecture.
Okay. No, actually in the Teams, I gave you guys a link and I asked you to install that particular one instead of.
Yeah, I didn't open Teams yesterday. I just saw it today in the morning.
Okay, so Discovery has less functionality. I didn't know that. Therefore, you can if you don't want it, you can uninstall it to save space and go to the particular link I have provided and install that particular student version. Okay. ANSYS student version will have the same format of the ANSYS installation what I have. Okay, Discovery is slightly different. Okay. All right. So so when you select the material, you already have the structural steel being selected. Okay. So if you want a different material to be selected, let's see here. We cannot do this here. You can add additional materials here. Okay, so if you want to add a different material, but first let us see what are the properties of structural steel that is given here. Okay, so in this particular case, let's see here. We have density, physical property density being displayed. We can expand this as well. We have isotropic thermal coefficient being displayed here. So what is isotropic material? Can one of you tell me what is isotropic material? What is an isotropic material? Anyone? Are you guys able to hear me? What is an isotropic material? Are you guys able to hear me? You have to respond. If you do not respond, okay.
I hear you.
I cannot. What?
I hear you.
No heat transfer, Doctor.
No heat transfer. That is isentropic. I am talking about isotropic material. What is isotropic material?
As in the properties don't change.
Let me.
Uniform properties in the material.
What? Repeat again.
Uniform properties.
Uniform properties. That is homogeneous, right? Homogeneous material is uniform properties all throughout the material. Or equal properties from location to location. So that is a homogeneous material. What is an isotropic material? Okay, so you have to recall an isotropic material is a material if you pick any point on the material and you measure properties in different directions, the properties are equal. Okay, so which means equal properties in all directions. Is there any material which is not isotropic? Is there any material which is
Composite
not isotropic?
materials.
Composite, yes. So if you take composites are orthotropic. They are not isotropic. What does it mean? If I measure, for example, Young's modulus along x direction, it is not equal to Young's modulus along y direction or z direction. Okay, so they have different properties in orthotropic directions. But isotropic materials will have the same value along x, y, and z. So they are isotropic materials. Most of your metals and alloys are considered to be isotropic, and we also assume them to be homogeneous material. If you take composites, they are neither isotropic nor homogeneous. They are inhomogeneous as well. Okay, so this is in short. If you take a structural steel, we are going to assume it is isotropic with respect to coefficient of thermal expansion. This is a property, and we assume along x, y, z directions they have the same coefficient of thermal expansion value. We also assume it has the same isotropic elastic property. So you are given here Young's modulus. In case you want to change the value from 200 gigapascal to 210 gigapascal, then you can change it here by double clicking and changing the values if you want to do that. Poisson's ratio, you can change it. So these are all static properties of the material. There are also other properties. So you can see here bulk modulus, shear modulus, etc. Rigidity modulus, that is. There are also other properties which are related to fatigue or dynamic properties. Okay, so in fatigue calculations, there are two methods we will see in further chapters. We will see that later. You have the stress life method, which gives you what is called as the SN curve. which lets you know what is the life of the specimen. And then there is the strain life method, which is based upon strain versus number of cycles to failure. We will see that later. And all these properties are also listed. Besides that, you have the tensile yield strength, compressive yield strength. They are equal for most of the ductile isotropic material. These properties are equal. You have the tensile ultimate strength as well. Okay. And if you want to input compressive ultimate strength, some value, you can double click here and enter the values. Okay. So after entering all these values and saving the data, you can close this tab and you can still see the green tick mark here. So we have selected the material for finite element analysis. This is the very first step. The second step is creating a CAD geometry. Okay, so how do we do this? Right click, I click on new space plane geometry. Okay, you can see here starting space plane. So wait for it until it opens. But if I right click again, you can see here other choices. There is the design modeler, discovery geometry. We are not going to use these two. We are going to stick with space plane interface. Okay, so let's wait for the other window to open. Once it opens, you can click OK. Now once it opens, you can see here the space plane window is open. Okay, you have the title space plane here. And the first thing we observe is there are many tabs here. You have the sketch tab, design tab, display, assembly, etc. So all these tabs are there. If you click on file, you can see that you can save this particular file in a particular format. Okay. So let's see the sketch tab here. Under the sketch tab, you can see different tools provided. So you have the clipboard. For orientation, you have the orient part of the tab. And when you look at this blue symbol here, on the right of the blue symbol, you have a drop-down menu. And under the drop-down menu, you can see different views for your window here. So what are the views? Right now, we have enabled trimetric view. If I click on isometric view, it goes to isometric view. Okay, again, if I click on top, changes to top view. So using this particular views, you can change the particular view you want. Okay, there is also a different method to do this, but let's go back to trimetric view before we do that. Then you have the create geometry toolbar here. You can create lines, circles, rectangles, and then we have few more choices. Again, we can create circles using 3-point method or center and radius method. Okay, so there are different methods to create the same shapes. Okay, so all these shapes you will create in a 2D plane. Right now, the 2D plane on which the sketch can be made is the XZ plane. So it is XZ plane. On this particular plane, you will be able to create all the geometries you require. Okay, let's see further here. Once you create these geometries, if you want to modify geometries, for example, if I create a line and a circle and I want to ensure the line is tangent to the circle, then I might use the modify tool bar here. Okay, once you have created 2D models, then you want to modify those models, you will use this modify toolbar. Whereas the constraint toolbar here, you can constrain some particular geometries. Then you have the edit one. So we will talk about this later, especially if you want to do some extrusion operation or fill a particular volume, then we can use this particular toolbar here. Okay. There is also enable 3D sketch. Sometimes we want to put a sketch or draw a line in 3D. So in that case, you will have to use enable 3D sketch because it will not be on the XZ plane. Right now, whatever sketch you draw will be limited to XZ plane. Okay, so now we have seen this much. So let's see some other tools here. On the bottom, you have selection cursor. Then we have again, if you click on this, there is the selection filter here. We will go through this later. We have the box selection mode here. There is the rotation mode. So if I click on rotation, you can see my cursor changed. I will be able to rotate the particular view. Okay, let's go back to the trimetric again. All right, so once I click on the rotation mode, I want to disable this particular function. I use the escape button on your keyboard to escape out of this mode. Again, there is the pan button here. If you take your cursor and leave above the pan button, you can see this is the pan button. Once I click on it, my cursor again changed and I will be able to center or move around here. Okay, I can move my figure. Sometimes you need to do this operation. Again, you want to escape, hit on the escape button. Okay, so that is one way to go. Otherwise, if you are on the pan button, again I click on the pan button, strong. Okay, so let's take a look at the particular window here. What do you see here? X and Z are enabled. All sketches are here. You can see the X, Y, Z axis. On the left corner here, bottom corner, you see the XYZ axis here. Okay, and if I move my cursor on the x-axis or y-axis, these particular axis, they become highlighted. Okay, now I want to see the XZ plane here by going perpendicular to y. What do I do? I go take my cursor to the left hand bottom corner, highlight the y-axis, click on it. If I click on it, immediately goes to this particular view. Okay, so this is another way to do that. You can also rotate your view here, see, by clicking and holding your left button and rotating this particular axis. Okay, all right, and let's see here. So now I want to go back to my trimetric. I click on trimetric view here. Now let's assume I do not want to draw on the XZ plane. Rather, I want to draw on the XY plane. How do I change the sketch plane here? To do that, I need to select X and Y axis here. Okay. So when I move my cursor to the y-axis, I can see my y-axis is highlighted, so I will be able to select it. But when I move to the x-axis, it is not allowing me to select the x-axis. So I will not be able to change the plane here in the sketch mode. So first thing what I do is I move out of the sketch mode. To do that, I click on the design tab. Sorry, I click on the design tab here, and on the mode toolbox here, we can see sketch mode. And if I move to the other guy, I can see the 3D mode. Okay, So I click on the 3D mode, the plane disappears. Now I will be able to select particular axis. Move my cursor to the x-axis, it is highlighted. I move my cursor to the y-axis, it is highlighted. So now I will be able to select. So let me move it to my x-axis. Use the control button in your keyboard, keep it pressed, and left click on the x-axis. The x-axis is selected. Now I move my cursor with the control button being pressed and not released. Take it to the y-axis, left click again. Now you can release the control button. Don't left click anywhere using your mouse. Now if you move your mouse without clicking anywhere, you can see here your x and y axis, they are selected. Now move your cursor back to the mode toolbox here and I click on the sketch mode. That's it. Now we can see automatically the sketch tab is selected. My x, y axis is selected for creating any sketch. Any doubt up till this point? Do you guys have any doubt up till this point? Okay, I assume you don't have any doubt. I will go to the...
No, doctor, no doubt.
No doubt, okay. Now what I want to do is I want to sketch on the XY plane. Okay, so to do that, I want to make the XY plane 90 degrees to my screen. To do that, I take my cursor to the left corner. I move my cursor to the Z axis on the left corner here, left click. Now I am on this particular plane. Okay. Now take a look here on the left part here. There is the tree structure which will be created as we create more geometries. Now, particularly right now, this tree structure doesn't have anything. What is a tree structure? You will have a list of elements which are created and connected to your design one here. So you can give another name also here. Let's say right click and rename, and let's say we want to give a name to this guy. Since we are creating elbow pipe, I'm going to write it as elbow pipe and enter. Okay. Now when I entered the name, you can see here that there is an asterisk mark. This means this particular file is not saved. So what do? I can save it by using files save as. Okay, I can use that, or so that will save your particular file here. So let me actually do that. Save. If I put save, you can see here space claim file. The extension of the file is going to be scdoc. Okay. Let's do one thing. I am going to save this particular file. Pipe. Since this is for section 1, I'm going to write it as section 1, and I will be able to save in this particular folder. So I'll save that. Once I save it, you can see the name changed and then the asterisk disappeared. Okay. But okay, so this is the space claim, but I want to save the workbench as well. I want to save the project as a whole. Since only the geometry is saved, what I do is I use file, save, and I create a new project file. Let's see here why it is a different location. Okay, I need to go to University of Bahrain. Let me look at the location here. Is that case? So let's see. Okay. This is not the one. It is not showing now. Okay. Not getting the location. Okay, so we have the here on the OneDrive. Go to this particular location here. I want to save it. Look at the project extension .wbpj workbench project. So the extension is different. I'm going to write the same name, but let's just remove the extension here, elbow pipe, and it will be saved with this particular name. So when I save the project, automatically the geometry is also saved. Okay, so the location you can see here, space claim geometry, it is saved here in this particular location. So let's go back to the space claim now. Keep observing the tree structure here. It will change as I create more and more geometries here. Okay, so let's click on the circle. I want to create an elbow pipe. How do I create it? First, I create the cross section, and then I'm going to extrude the cross section to create an elbow pipe. That is the idea. So first, I create a circle. It is a hollow pipe. I create the outer circle. Left click, it selects the center of the circle. I extend it, and when I extend it, you can see the diameter of the circle is coming out as highlighted as 22.8. Don't left click. What I'm going to do is type in the value of the diameter I want. So let's say I want 20 millimeters. That is the diameter I want, and press enter. Okay, so the circle is created with 20 mm diameter. This is the outer circle of for the cross section. And if you take a look at the toolbar, the circle is still highlighted. Okay, it will be highlighted until you press the escape button. Now I want to create another circle, the inner circle. First, I select the same center, extend it. The blue highlighted portion is showing as 16.97. I want to change it to 18 mm. So I type in using my keyboard and press enter. So the inner circle is created. Now you look at the tree structure here. As we were doing, the tree structure got changed. I expand the tree structure. We have the sketch. Two circles are created. Okay. Now, what do we want to do? We want to extend the portion in between the two circles, or extrude the portion between the two circles in the Z direction. Now this is the XY plane, so obviously I want to extrude it in the Z direction and create an elbow pipe. Okay, so to do that, what do I do? Now I go to the design tab. Keep watching the tree structure here. Go to the design tab. Nothing happened to the tree structure up till this point. Now from the sketch mode, I'm going to go to the 3D mode. As I click the 3D mode, the tree structure will change completely. Observe, I clicked it, the tree structure changed. Now it has created a surface. Let's go to the trimetric view, and we can see here the x-axis, the y-axis, and the z-axis and automatically the pull here, the pull command is highlighted and activated. Okay, but if I take a look at it, let's say if I left click it and move around, you will see it will extrude this entire structure, but I am not ready for it yet. So what I do is I escape and enable the select button here. I want a hollow pipe. I do not want a solid pipe. Therefore, I want to delete the central part here. So highlight the central part. So if I move my cursor around, you can see different parts get highlighted. So this surface, I want to delete the inner surface here. Right click and you will see the delete option here. Delete. So that particular surface is gone. Now only the solid surface is here. Okay. Now the next case is I want to use the extrude option or the pull option here. So I select the particular area first, and then let's say I select pull. When I go here, I can see the pull option is enabled. You can see the two yellow arrows. I can extrude it in this direction by left clicking and pulling it this way or the other way. Okay, so if I do that, let's see what happens. Left click, you can see here extrusion. And I don't want to do that, so escape. Okay, I press the escape button, it came out of it. Now, what I want is an elbow pipe. The elbow pipe will have a bend in one direction after I extrude it along the Z. So how do I do this? There are a couple of options when I enable the pull option here. You can look at this revolve option. You can revolve and create, for example, if I want to revolve this with respect to a particular axis, Z axis, if I rotate it with respect to the X axis or Y axis, for example, I will create a hollow sphere. Okay. What about this? This is the pull direction. And you can also rotate it with respect to a particular axis in up to a certain limit. Instead of rotating it 360 degrees, I can rotate it to a particular level and leave it. Okay. There is also the sweep option. This is the option I'm going to use. When I move my cursor on the sweep option, it clearly shows select the lines or edges along which you want to sweep the selected face or edges. You can select multiple connected lines and edges that form one trajectory. Okay. So to use the sweep option, I need to first come out with a trajectory along which I want to extrude this particular cross section. So how do I do that? Right now I should exit out of the pull option here. So I select the select button, select cursor here. So I'm out of the pull option here. The next thing I want to do is I want to draw a trajectory. So in which axis I want to draw the trajectory? The trajectory will be drawn on ZX plane. So now I want to create another sketch which shows the trajectory by lines. So first I have to enable the XZ plane for a sketch. So I move my cursor on X-axis, press the control button, left click and select the X-axis. Keep the control button pressed, move to the Z-axis and again left click, X and Z axis are selected already. Now I go to the sketch mode on the design tab, click on sketch and you can see the XZ axis is enabled for the sketch. Now you can draw lines to create any trajectory. Left click and create a line. Okay, so I start with the center. I want to extrude it in the negative Z direction. So let me start here. Left click, and I want perpendicular to the Z direction. If I move the cursor around, you can see it creates an angle with respect to Z axis. Maybe it is with respect to X axis. It's not very clear. So we'll see that later. And I can also move it along the Z-axis. I want to create a trajectory for a particular length. Let's say I did not left click anywhere. Don't left click right now. You can see 19 mm is highlighted. So I want to create a line of length 150 mm. So I'm going to type it here with the keyboard 150 and press enter. So it creates a line of length 150. Now, if you observe the toolbox, still the line is highlighted. So when I move my line, another line will be created. So let's assume I want to create another line at a certain angle. Let's see this angle. For example, with respect to the Z-axis, the angle is given. You can see 124.7 degrees, etc. Okay. Now I do not want to use my mouse. I don't left click. Observe that 46.23 mm is highlighted. And if I use the tab in your keyboard, I can move in between the angle and the length. So I click tab once, my angle is highlighted, 124.7 is highlighted. Again, click on tab, 46.23 is highlighted. So I go to the angle. I want to create a line at 150 degrees. Let's assume that 150. Type 150. Do not press enter now. You want to also change the length of the line, second line. So click on tab button in your keyboard. So if I click on tab, it goes to 46.23. I want to create a line of length 150 mm again. So I type in 150, and now I'm ready to press the enter button. Press the enter button, and then it creates another line. You can still see my line command is highlighted. So what I do not want to create any more lines. I hit on the escape button on your keyboard and escapes out. And you can see here still it is highlighted. What do I do? Here, so we have created the, so I think it is escape button. Click on the escape button and it comes out of the line. Now the lines are created. The trajectory is there. However, there is a sharp corner between the two lines. The trajectory, I want the trajectory to have a smooth transition from the Z direction to the inclined direction. So how do I do that? I am still in the sketch mode. I have created two lines, but I want to modify the lines, connection between the lines. So I go to the modify toolbar here, and there are a couple of modify toolbars. You can take your cursor and leave the cursor there. It will give you an explanation what it is. Click and drag a straight line or aced line to bend it or change its radius. So we do not want to do this. The other one, click on a plane or planar surface to set the mirror plane, etc. We do not want to do this. Trim away, we do not want to do this. Again, this is also a create corner. Click a line, create corner by trimming. No, we do not want to do this. So if you go to the left top, we have the create a rounded corner. That is what we want to do. Okay. So what does it describe? Click a line, then click another line to create a corner by trimming or extending the lines with a tangent arc. So I want to do this. I left click on this particular option. I go and select one of the lines here. Okay, I have selected one. Then I want to select the second line. So don't select it yet. To select it, I want to give the radius. So again, the radius is highlighted 124.97. Let's say I want to input some radius, same 150, and then enter. And then you can see here the connection between the two lines are smoothened by a curve. So this is the trajectory along which I want to create an elbow pipe by extruding operation. Okay, so now I have the trajectory. So let's go back to the design tab and go to the 3D mode. Okay, so this is the 3D mode. Now we can see this particular geometry is too small. I cannot see it. Now what do? I keep my cursor here and use the wheel. If you have a mouse, you can use the wheel and rotate it forward. It gets smaller, rotate it backward, gets a little bigger. You want to pan, bring it to the center. Let's see here. I think this should be enough. And if you want to zoom in a little more, you can use the button here, the wheel and the button. Okay. So what I want to do now, maybe I want to make it a little bit lesser, but before that I just want to select my surface. After I select, I zoom out a little bit so that I can select all the lines. I should be able to select all the trajectory. Okay, so now I am in good position. I can select all the trajectory. I select the pull here. Okay, then I select the sweep command. Okay, so what do I do with respect to sweep? Leave the cursor there and read it for a moment. Select the lines or the edges along which you want to sweep the selected face or edges. You can select multiple connected lines, edges that form one trajectory. Okay, so now I want to select the trajectory. Select this. Select. So we have to enable the control, use the control and select both the lines. Use the control button, keep it pressed and select all the three lines. Once you have selected all the three lines, okay, so it's clear, use the pan and you can see it is selected. I'm going to move it and leave it at the end point here, or I can zoom out so that the entire thing is visible. Okay, now it is visible. Now what I do is, after selecting the entire trajectory, I go to this particular selection up to end point. Click an object to specify the destination to which you want to move the selected object. If a move handle axis is selected, the selected object moves only in that direction. Okay, so here I'm going to click on this particular option, go to the end point and left click that. That's it. So once I do that, you can see here clearly the elbow pipe is created. So let's see here, what is this? This is revolve. So we do not sweep to the end of the trajectory. So we could have used this as well. It doesn't matter. So either way, the pipe is created. Elbow pipe is created. So we are done with this geometry here. Now you can see that it is asterisk mark over here. We can go to the project and just click on save. Automatically everything will be saved. Whatever is there on the project, including the spacecline file will be saved. So you can see here sys and there was a asterisk mark. It is no longer here. Okay, so now we have the geometry, and we can see here there is a green tick mark which appears. That means we are completed with the geometry. So let's close this SpaceClip object here. All right, so now we are ready to create the finite element model. Right click, edit. Wait for it. You can see on the left corner, starting mechanical. Until it opens, you have to wait for it. So it has opened it up now. Click OK. Go back to the model. Wait for the geometry to open. Still it is loading. You can see all the tools are not loaded. Just wait for it. Okay. So now it is, the geometry is loaded right here. On the left, you can see the project, geometry, materials. All these are with a green tick mark. That means these things are, these particular functions are done. You can expand them and take a look at it. Then there is the meshing option. What is a mesh? In finite elements, you usually divide the entire component into small elements, 3D elements. And these 3D elements will be used to calculate the stresses in each element. Okay, so you have to divide the entire part into different elements. So let's go to mesh here, and let's see if you want to do some sizing, contact sizing. So for now, what I'm going to do is I'm not going to change anything here. Leave it as such. And we want to generate mesh. So right click on it and create generate mesh. It will create with default properties. And you can also use generate mesh here by clicking on the generate mesh toolbox here. So let's see here. Let's calculate generate.
Victor,
Yes, I know the time is up.
can you leave this?
Yeah.
Yeah, we're really tired. It's already 2 hours.
What? Can you repeat? I cannot hear.
If you can leave it to another class, it will be better.
Okay.
Yeah,
I understand you are
already
tired. I am
tired.
also
2 hours.
tired. We will stop right here. Okay, so this is how you generate mesh. We will talk about more parts later. Okay, in the next class, I will continue from this part, and we will see how to create stress plots, etc. in the next class. Okay. Any doubt up till this point? If you do not have any doubt, I'm going to stop right here.
No doubt. Thank you, Doctor.
So I'm going to save this so that we can use it in the next class. All right, so see you guys, and I will meet you again next class on Sunday. Okay. All right.